Okay. Trig functions, and then you can write f of x. You know what f of x means, ne? What does f of x mean? Y. Okay. All the functions work the same, whether it's sin, cos, or tan. So I'm just going to, for the sake of explanation, use sin. Is that fine? Okay, those are the 4 possible variables that you can have in a function. Jude, UDE. Go. To calculate the amplitude of a graph, you always take the maximum value. Let's just put here the maximum y value, no? Maximum y minus the minimum value divided by 2. And then you look whether it's positive or negative. Now, in order for us to be able to know whether it's positive or negative, you need to know the 3 mother graphs. You need to know that sin, if you have a small y-axis and an x-axis there, it starts at 0 and 0, and then it goes up first and then down. Okay, that's the standard sin. The standard cos, it's going to look like this. It starts at the top, goes down, goes up again. And then the standard tan, do you know where those asymptotes are? 90 and 270. So it starts at 0 and 0, it goes up. Okay, so in order for us to know the sin graph is negative, it would start by going down and then up. Second. It's the same as these graphs. Can I quickly close here to open a graph page for us? You'll get these on the board. Okay, there's your standard sin graph on the board as well. So the amplitude will be the value in front of the function. Okay, so I want you to look at we are going to talk about the period of the graph later, but you see that the period of this graph is 360 degrees. No? Its maximum value is 1. Its minimum value is -1. There, if you wanted to calculate the amplitude, you would say 1 minus -1, which is 2, divided by 2 is 1. And do you see that there is no value in front of sin? So therefore we know the amplitude is 1. If it was -1, do you see what happens? It flips to the bottom. So instead of starting at 0 and 0 and going up, still going to start at 0 and 0, but it's going down. Okay. So if I put in a 2 there, look at the period of the graph. It doesn't change the period of the graph. It only applies to the height that it goes up and how low it goes. So in order to calculate this specific graph's amplitude, we would say 2 minus -2 is 4, divided by 2 is 2. And do you see it there? But now if, for instance, it was -2, look at the catch that they do. You see the maximum is 2. You see the minimum is -2. You would still say 2 minus -2. You would still get 4. Divide by 2, which is still 2. So you see the calculation doesn't give us the negative. That you have to determine by yourself, by knowing what the mother graph looks like. Okay. I want to show you if the graph has been translated upwards. Let me just bring down this Okay, if you had this graph, you would go and look for the maximum value, which, let me just put it there so you can read it, is 3. Okay? And the minimum value is -1. So 3 minus -1 will still give you 4, divided by 2 is 2. So do you see whether or not the graph has been translated upwards or downwards or whatever, our calculation will still work. If the function looks like this, plus 3, the maximum value is 4, the minimum value is 2, 4 minus 2 is 2, 2 divided by 2 is 1. So you still get that amplitude value, which is correct. Do you all understand amplitude? Right. Okay. The next one we are going to look at is going to be the B value. It's going to go on now. Just give it a second. It's freezing again today. Okay, the B value. Now, I want you to be careful of B. Okay, the reason I'm saying that is that I need you to understand that B is not the period. Okay? But B influences the period. Okay? Let's write it there. Is that how you spell influence? Okay, so to determine the period, you're going to take the standard period of the graph divided by B. That will give you the period of the graph. Okay, so what is sin standard period? 360. And cos? And tan? Okay, so for example, if you had f of x equal to 3, no, let's not write that 3 there, tan 3x. Tan 3x. You all know what the period is, né? It's how long it takes for the graph to make a full wave. And the question in the paper might be, what is the period of this function? And then most learners write, the period is 3. Okay, that can't be true, né? Okay, so what I said is that you take the standard period, which is 180 degrees, and you divide it with b, which in this case is 3, and then you get the period of the graph, which is 60 degrees. Now let's quickly look at the graph when we draw it. Tan 3x. Okay. If you look at that, do you see that the graph has been squished in? Let's compare with the standard graph. There's the standard graph. Okay. There's 360 right there. Okay. So if I put in the 3, then how long does it take to make a complete wave when it starts over again? 60 degrees. Does that make sense? Okay. Now, why the period is very important is because of the critical points. The critical points of the graph is where it's turning and where it cuts the axis. Okay? So now, if the period is 360 degrees, look at the standard sin here on the board. It starts at 0. Where is the first critical point? 90 degrees, there it turns. And the second one? 180, there it's at 0. And then again? 270, and then again? After how many degrees is it every time? After every 90 degrees. Let's look at cos. 0, 90, 180, 270, 360. Okay, now if you don't know what the critical points of a graph is, then you might go to tan. And you would think it's every 90 degrees. Every 90 degrees. Now you would say, they give you the function and you are now trying to get the values to plot them. You would say tan 0, you'd get 0. You would say tan 90, you would get error. You would say tan 180, you would get 0. You would say tan 270, you would get error. You would say tan 360, you would get 0. So you will have 3 points of 0 and 2 errors. Do you see that's not enough information to draw the graph? Okay. So how we calculate those critical points? Let's look at the standard sin. You guys said that it's every 90 degrees, né? How do you get from 360 to 90? Divided by 4. Okay. 360 divided by 4 will give you the critical points. At every 90 degrees, something is happening. So let's go back to tan. 180 divided by 4, do you know what that is? 45 degrees. That means you're going to have a critical point, a special point that you need to draw at every 45 degrees. So at 0, you will get 0. At 45, you'll get 1. At 90, you'll get error, which is asymptote. At 135, you'll get negative 1. At 180, you'll get 0. At 225, you will get 1. At 270, you'll get error. At 315, you'll get negative 1. At 360 you'll get 0. But saying that, if you don't know the shape of the graph, you will only have a dot there, a dot there, an asymptote there, a dot there, a dot there, a dot there, an asymptote there, and a dot there. So that will be very hard because it will look like that. You won't know what's going on. Does that make sense? So therefore you still need to know the shape of the graph in order for you to draw it. Okay? Alright, so back to this tan 3x. If our period is 60 degrees, where will the critical points be? You're going to have to take 60 degrees divided by 4. What is 60 divided by 4? Let's just check. 15. So at every 15 degrees, you will have a critical point. Easy, ne? Okay, so to find the critical points, okay, then we get to two familiar ones. P, which is the horizontal translation. What do you think it means when you have sin x plus 30? How did the graph move? 30 degrees? To the left. 30 degrees to the left. It's the same as with algebra, no? And minus 30 is going to be 30 degrees to the right. Okay, I just want us to finish writing for Q as well, and then we will look at the graphs or at the sketching. Okay, if it is sin x plus 2, what does that mean? 2 up and minus 2, 2 down. Just like algebra. Do you know what's on the x-axis? Look at the standard functions. On the x-axis, it's the degrees. Do you see that? And on the y-axis, it's the normal numbers. So don't go and if it's sin x plus 2, think that it's plus 2 on the x-axis. X is degrees. Y is the normal numbers. Are you done? Alright. Let's look at what happens here. If I have x plus 30, the standard, look here at the standard sin, it starts at 0 and 0. Now this sin graph starts at negative 30 and 0. if I say minus 60, the standard sin supposed to start at 0 and 0. This one starts at 60 and 0. Plus 2, the whole graph is translated upwards, 2 units. Minus 1, oops, that's 12. The whole graph is translated downwards, 1 unit. That's it. Okay. But this whole set of information does not help us if we don't know the standard graphs. Okay, you must know it. Now we are immediately going to go to those Trig question papers that I sent you. Oh, that I gave you. I handed it out, no? Not yet. Okay. Quickly hand it out. Okay, let's start with the first one. Okay, so in a question paper, they are always going to give you the information like that, saying which functions those are. Okay, because do you remember when we worked with co-functions? We saw that any sin graph can be, or any sin function can be a cos function because of co-functions. And every cos can be a sin. So therefore they have to tell you whether it's sin or cos. Because otherwise it can be either of the two depending on how you've moved it. Because a sin graph is just a cos graph moved 90 degrees. Look, that sin graph is this cos graph, but it starts 90 degrees later. Do you see? Okay. So sin x minus 90. That means sin 90 degrees, or plus 90. Sorry, plus 90. The sin graph moved 90 degrees to the left is cos. Okay, so that's very important. They gave you f of x and they gave you g of x. Now, if you look at f of x, they say you have cos x plus q. Let's just look at the equation. What is the amplitude of cos? 1. If there's no number, we know it's 1. What is the b value of cos? 1. The one that's right in front of x. That's also 1. So therefore, just looking at that, what is the period of the cos graph? 360. You take the standard period of cos, divide by the value of b. So that one doesn't have a change in the period. Okay. There is no degree value added or subtracted in brackets. So therefore we know it hasn't been translated left or right. But there is a plus q. That's a variable. So that tells us that this graph might have moved upwards or downwards. Okay. Now tell me, where is the standard cos supposed to start? You can look here. Where is the standard cos supposed to start? 0 and 1. At x0, at y1. Now let's just look at this graph. Where is this graph starting? Where is it when x is 0? It's a half. So has it been moved up a half or has it been moved down a half? It has been moved down a half. So already you can find the value of q. It's minus a half. Okay, let's look at g of x. What is g of x's a value? 2. What does that mean? What is a value again? Amplitude. That is the maximum minus the minimum divided by 2. Now let's just look at the maximum value we have there. It's 2 and the minimum is -2. So that works out perfectly. Okay, then it has an unknown value in the place of b, given as b. Okay, what does that tell us? What has been influenced? The period. What is the standard period of a sin graph? 360. Okay, now if we go to this work that we wrote down here about b, we said the standard period divided by b gives us this period. But now we're going to need to find the value of b. So can I manipulate this equation to find b as well? You just swap b and the period of this graph. Okay, so look at that graph. What is the period of this graph? How long does it take to make a complete wave? 120. Now let's pretend they didn't give you that part. They only gave it from -60 to 60. Would you be able to find the period still? If they only gave you that part, would you still be able to find the period? Yes, because you've got half of the wave in 60 degrees. So how long would it take to make a full wave? If they only gave you that part, would you be able to find the period? Yes, because you know what the graph is supposed to look like. It's got an up, and then a down, and then another down, and then another up. So you only need a quarter of the graph, visually, to know what the period of the graph is. Okay, so, but this one is easy. We can see it's 120 degrees. So what is the b value gonna be? What's the standard period of the sun? 360. What is this one's period? What's 360 divided by 120? Highball. 3. 3. So the b value is 3. There's no value being added in brackets and there's no q value either. So there's no p and there's no q there. Okay, so that's what we got from the information there. Now we can answer it. Let's start. You can write down in your books, question 6.1. Write down the coordinates of the maximum turning point of G in the given interval. Can you write that down? What is it? Coordinates. No coordinate. Where is it reaching its maximum? At 30 degrees. What is the maximum? 2. Okay, that's how you see the coordinate. Ne? Which x gives it? What does it give? So in brackets, you write 30 and 2. Okay, next question. Determine the values of x for which f is strictly increasing in the given interval. Okay, I told you guys when we did this with algebra, you can use a ruler. Strictly increasing. So if I always walk from left to right, ne? On f now. Am I going up or am I going down? Up, 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 up. Down, 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 down. Do you see that? Okay, so where is it strictly increasing? From negative 60 to 0. Does that make sense? Okay? And now you remember these questions at algebra, we need to decide is it included or excluded and those things, no? Okay, so let's look at negative 60. Should negative 60 be included or not? Remember, you must now interpret what is happening after or before this negative 60. Because this graph isn't turning here, it's going to go down. So therefore, at negative 60, it's already increasing. Does that make sense? Okay, so negative 60 will be included. You can use a block bracket. At 0, will it be included or excluded? What's happening at 0? It's turning. Do you remember the parabola? Was the turning point a place where it increases or decreases? Constant. So at 0 it's not increasing, it's constant, because right after 0 it's going down. So therefore, round bracket. Determine the values of Q and B. We said the standard cost is supposed to start at 1. This one is starting a half downwards. So therefore, what is Q? Dankie, who said that? Negative. Negative a half. If you said a half, you are saying it's plus a half, ne? You must put in the minus. And the value of B, this is now the value of Q, ne? Okay, the value of B, we're going to say the standard period divided by the period. Just write PER so you don't think it's divided by P, because you know there is a P variable, ne? Okay, so it's going to be 360 degrees minus 120 degrees, and that gives me an answer of 3. Use your graphs to determine the values of x for which 2x sin 3x minus sin 3x greater than or equal to 0. Do you understand what's going on there? No. Do you have a function that is 2 cos x sin 3x and sin 3x? You remember the graph that you have here is cos, let's just write it down with these values that you have cos x minus a half, this is f of x, and you have g of x equal to 2 sin 3x. So even though it says sin 3x there, it's not the graph that you have. Do you understand? Is there something, anything, that you can see in the two terms that maybe repeats or is similar, we can take out or we can divide or whatever? Sin what? Sin 3x. Ne? What do you think we must do with it? We can do two things. Okay, the first thing we can do, because you see this is an equation. So that's good. When I divide things, I can get rid of it. Okay? If I divide with sin 3x, it's going to get rid of it here and get rid of it here and get rid of it there. But then I'll have a function cos x, 2 cos x, what. So we can try that, no? Okay. You can also take out sin 3x in common and then divide it. Okay, let me show you. Let's start by, did you want to take it out or did you want to divide it? Take it out. Okay, I thought so. Let's take out the sin 3x. Then what's going to remain is 2 cos x minus 1 greater than or equal to 0. It's looking better, but it's not looking good yet. So that is why now I would divide to get rid of it. So here I would have 2 cos minus 1 greater than or equal to 0. Oh, this is just x, sorry. Just put in your x's. Is there anything we can do now? Because this still doesn't look like the functions. Bukang? We get the function alone. Yeah, that's what we did when we did the normal trigonometry as well. No? We got the function alone. So I can take this one over. Now I just want to show you two options. If I take everything over, it's going to be cos x greater than or equal to a half. Now the problem I have with this at this stage is that I don't have cos x function. So you must remember, whenever we work with graphs, because you see they are saying use your graphs, we need to try to get our equation here to look like either one of the graphs. Okay. So the better plan we would do here is to divide everything with 2. Then I would have cos x minus a half greater than or equal to 0. Now I have one of the functions. Okay. So I want you to draw a line under this. You can copy everything, and then we're going to do 6.4 again. 2 cos x sin 3x minus sin 3x greater than or equal to 0. The question says use your graphs. Now you saw what can happen. You saw things that we can do, possibilities. But now you know what we want to do. We want to sort this thing out so that it looks like our functions. either saying where is f of x greater or equal to 0, or g of x greater than or equal to 0, smaller than, or where is the one graph greater than or equal to the other graph. Whatever, we don't know what it's going to be, but we need to manipulate this thing to get our function. Now let me show you a possibility. If we consider that g of x function, trying to get 2 sin 3x, if I divide with cos x here, I would have 2 sin 3x. Do you agree with me? But if I divide with cos x here, I wouldn't be able to do anything. It can't even become tan because this is 3x and cos would be x. So can you see that is not an option for us? Okay. The other thing we can do is, like we said, we take out the sin 3x in common, or you can say you divide with sin 3x. You understand that those two are the same, no? So I'm just going to say divide with sin 3x. Divide with sin 3x. And then I'm also dividing with sin 3x here, no? But dividing 0 divided by anything is just 0. So here it cancels out. Here it cancels out, and here it becomes 0. So I'm left with 2 cos x minus 1 greater than or equal to 0. Now at least I only have one function, which might be the function f. It looks a lot like it. But what does this one differ from f of x? F of x is cos x minus a half. This is cos x minus 1. But there's a 2. So if I divide this one with 2, I'm going to get rid of that 2 there, which I want. And I'm going to have a half there, which is what I want. Does that make sense? So now that you know what you want to do, it's easier to see what we are going to do. So now I've got cos x minus a half greater than or equal to 0. So what is this whole terrible question actually asking? Where is the f graph above the x-axis? Where is it positive or equal to 0? And now we can go to our graph. Let's just quickly look at it. At negative 60, it is 0. Then it's at the top, which is what we want, né? Up unto 60, and then it's going down. So from negative 60 to 60, we will now see whether it's included or excluded, né? But you agree with my interval there. Negative 60 to 60. Okay. The question is greater than or equal to 0. So must negative 60 be included or excluded? What is it at negative 60? It's 0. And I want greater than or equal to 0. So therefore it's included. What must it be at 60? Or am I going to include or exclude? Include, because at 60 it's 0. And they're asking greater than or equal to 0. Do you understand that? Okay. Now we're going to quickly do question 7, where we draw the graphs. Given f of x a half tan x and g of x equal to sin 2x. They say draw the graph of f and g for x an element of negative 90 to 180 on the special answer book. Show all the turning points and intercepts of the axis. Clearly show the asymptotes using dotted lines. Okay. So we are going to start. We need to do some planning first, and that's about our axis. Do you see that they give you the interval for the x? They're always going to have to do that. It's from negative 90 to 180. Was that difficult? No. Okay. If it was a standard tan, okay, we will go on with it tomorrow. We'll draw it tomorrow.